recognize that the generation mix is changing. We recognize that consumers want to get more engaged in the electric side, their energy side at their homes. They're looking at on-site generation, PV systems, energy storage systems. They're looking at how they can participate in demand response programs. They're looking at electric vehicles and how that could play a role in the future. We're also adding technologies from the sensing technologies, whether you're talking smart meters, whether you're talking synchrophasers, whether you're talking frequency data recorders on the distribution system. What we're trying to do is actually get a lot of value. We want to start with data. We want to pull information. We want to do analytics. And then we ultimately want to provide decision capability for the utility, the grid operators, and customers. And that is what the smart grid is all about, is providing that ability and flexibility on the system. One of the biggest things that we could do to resonate with the customers was look at outage management, look at the restoration process. I would say that we spend a lot of time with the emergency response side of saying we need to have a very effective restoration process as we look at emergencies. There's a lot of decisions that are going on in the federal government. Decisions of, do we put an emergency diesel genset at gas stations or at other critical infrastructures? Or can we rely on the electric grid being restored in the time that was indicated it would come back on? So where has DOE been, and what has DOE been working on? We have been working through the American Recovery Reinvestment Act. We have put over $4.5 billion of investment into the electric grid, looking at information technologies, capabilities for the electric grid, starting with advanced meters. Over 15 million meters have been deployed. We have deployed over 9,000 automated feeder switches. We have done over 800 phaser measurement units on the system. All those are building blocks for the capabilities that we want to achieve. We are seeing benefits from that. Our goal was actually to have those capabilities come out with the utilities through outage management systems, through the ability to do CVR, conservation voltage reduction, the ability to actually have more switching and routing, better reliability, improved services for customers. Also for data and data management. Where do we want to go? What I want to drive to is better asset management, looking at predictive failure. We've been working with utilities to better understand how their assets are performing on the system. As the business models evolve, we're going to have more third-party players. We're going to have more on-site generation, more distributed generation. We're going to have more engagement by the utility commissions. We need that information. We need that ability. There's a direction looking at how do we want to evolve to microgrids. That means a third-party operated grid. How are we going to look at that in the future for the safety of the workers, the community, the people that are engaged in those activities? The biggest hindrance is actually that lack of information of what's going on, what's happening, and how can we ensure some security and reliability. So from those basic principles, I think we need to think about that and utilize it. But on the flip side, that means a lot more information technologies, a lot more connections, a lot more components on the system. How do we look at those components from a safety perspective? So a lot of work to do. I came here with my sleeves rolled up. I really encourage us to take a broad, thought-provoking exercise and think about where do we want to go in the future as the grid continues to evolve.